ladies and gentlemen, welcome back to another video of the Concoction Series, where we continue to look at the set theory problems on the problem set. Ooh, that sounds smooth. On the problem set of the first volume of the Concoction Series. In the previous video, we saw how to list elements of a set that are described using the set builder notation. And in this video, we'll be looking at how to play around with getting the members of a particular set. All right, let's get right into it. Yeah, the problem 3 here is asking us to determine whether these statements are true or false. So we're given two sets, A and B, where A is the set of the letters F, G, H, I, and G. B is the set of the letters T, U, and V. And C is the set of the letters 7 to 11. 7, 8, 9, 10, and 11. So we recall that the symbol E represents or means belongs to or is an element of, while when it is crossed out, it means does not belong to or is not an element of. So for instance, we could have something like Sunday is not an element of the set of the years, or sorry, months of the year. Months of the year. So that being said, we can now start looking at each of the statements here. The first one says A is an element of the set capital A. That is obviously false, because when we look through the set A, the letter A, the small letter A, is not an element. So the answer to this is false, the first one. The second one, F is an element of A. So is that true? Is that a true statement? I think so. F is obviously sitting down as one of the members of the set A. So this is true. The third one, it says K is not an element of A. Is that statement true? Is K true? Is K is K an element of A? The answer is no. So it means that the statement is true, because K cannot be found as one of the elements of A. The next one, P is an element of B. So when we check the set B, we find out that P is not a letter that is an element of B. It cannot be found as one of the members of the set B. So that statement is false. The next one, T is an element of B, which is true. We can truly see that T can be found in the set B, so that is true. And the next one, which we have to be very careful about. So the question says -3 is not, or -3 is an element of Z. So the question is, what does that Z stand for? So it is one of the number systems that we have. So let's have a quick review of the number systems. So the first number system that we have, the first set, is the set of natural numbers, N, which are just the whole numbers, the counting numbers, 1, 2, 3, and so on. And these sets are contained in a set of integers, which consists of both positive whole numbers, negative whole numbers, and 0. So this is 0, plus or minus 1, plus or minus 2, and so on. And this set is contained in the set of the rational numbers. So this first one, the natural. The second one, the integers. The next one, the rational numbers. And from the name, ratio, rational. These are numbers that can be written as a ratio of two integers. So we have a over b such that a and b are both integers and b is not equal to 0. Before we have the set of the real numbers, and finally the set of the complex number. So complex. So the real numbers are all the numbers, including both the rational numbers and the irrational numbers, from negative infinity to positive infinity, while the complex numbers are simply an extension of the real numbers, where we include the imaginary numbers. So a plus bi, where a and b are real numbers, and I, which is equal to the square root of -1, is the imaginary number. Okay, that being said, we can come back and finish up what we've said here. So it's -3, an element of the set of integers. So from the description we have of the integers, it includes both positive whole numbers and negative whole numbers. So definitely -3 is an element of this set. So that is true. The next one, 20, is an element of. So when you look carefully, you see that this C is the boldface C, and not the ordinary C for which the sets were given or described. So this is a little trick that people might fall victim of. So 20 is an element of the complex number. That is true. But 20 is not. So it is true that 20 is an element of this. This is true, because all real numbers are complex numbers. But it is not true that 20 is an element of C, where C is a set that were given originally. So this is also true. So it means that this statement, 20 is an element of a complex number, is actually true. People will get carried away and look at the set C given to us and say, oh, 20 is not there, and they think that the answer is false. Okay, but it's true. Then the last one, 5 is not an element. The next one, 5 is not an element of C. In this case, C is talking about the C given to us in a question, and truly 5 is not an element of that set. So it means this is true. Then the next one, 9, the set 9. There's a difference between writing this and this. So this is the set containing the element 9, while this is just an element 9. So while 9 as an element, is an element of set C, so it is right for us to say 9 is an element of C. But since this is a set, it doesn't make sense for us to say this set is an element of C. It makes sense rather to say that the set 9, the singleton 9, is a subset of set C. But as an element, that doesn't make sense, because C is not a set of sets. So in this case, the answer is false. It doesn't make sense because C is not a set of sets that contains the singleton 9. Then finally, 10 is an element of the set of the natural numbers less than 10. Of course, that is false. Natural numbers, although 10 is an element of the set of natural numbers, but because of the condition numbers less than 10, it is not true that 10 is less than 10. That is false. And that completes the problem set. So we'll meet again in the next video. If there are anything that you need further clarification on with this particular video, kindly point it out in the comments. Thank you.